Let's talk about the absolute value, what that does to graphs. This is the actual definition of absolute value. So, absolute value of A will be A if A is greater than or equal to 0. Otherwise, it's negative A if A is less than 0. So essentially, we always end up with a positive number. Basically, the way we think about it is we're talking about its distance on the number line from 0. How far away is this number from 0? Because we're talking about a distance, then it's a positive number. It's always positive. So it's magnitude only. The direction, whether we're going in the positive direction or whether we're going in the negative direction, doesn't matter. We don't consider that. Some results, and they may look silly, but these are the results of how we manipulate absolute values. We know the absolute value of negative x will therefore be the same as the absolute value of x. They are both the same distance away from 0. If we subtract x from y, we'll get the same as when we subtract y from x, if we're taking the absolute value. Same with multiplication here. It doesn't matter. Look, absolute value is like a grouping symbol. You could even think of that as like we've factorized the absolute value of x outside of that grouping symbol. Division, same idea. The absolute value of x squared would be x squared, because when we square we always get a positive number anyway, so we don't really need the absolute value signs on that one. And this one here is the one people often get wrong, the square root of x squared. The square root of x squared is not x. The square root of x squared is technically the absolute value of x, because we're saying the positive square root, so we should end up with a positive number. Let's do some simple little ones there. So absolute value of negative 5, well, that must be 5 units away from 0, so 5. Absolute value signs are like grouping symbols, and we know our order of operations. We always do what's inside the grouping symbols. So 6 minus 8 minus 2 is of course negative 4, and we get 4. We do the grouping symbols first in our order of operations. So 6 times 3 minus 20 is negative 2. The absolute value of negative 2 is 2, so 7 minus 2 is 5. 3 outside, again, like I say, it's like grouping symbols, the same as we do with algebra. We don't generally write the multiplication sign. That just means 3 times the absolute value, so we get 18. Now this one you've got to think about. The square root of x squared if x is less than 0. What is the answer? And the answer is negative x. Because if x is a negative number, but we've now defined the square root of x squared to be the absolute value of x, then we should be getting negative of x, because if x is a negative number, we go negative, negative, and that would therefore make it positive, which we need it to be. So if they have defined x to be less than 0, then the square root of x squared would be negative x. Right. The graph. What does the graph look like? Absolute value of some linear function, mx plus b. What does it mean? Well, it means that bit of the line that's below the x-axis will reflect above, because we can only get positive numbers, so it can't exist underneath the x-axis. So the bit below reflects above, and we end up with a V shape. The most classic of them all, the absolute value of x, there it is, our V shape. So you could imagine that the line y equals x, but the bit below we've reflected above. When we're drawing it, it's always good to put some sense of scale on it. So we usually label a couple of points there, so we can say, right, goes through 1, 1 and minus 1, 1, gives it a sense of scale. So I had to draw this one. We've now got a couple of ways we could do this. I could do it this way and say, well, look, it's the basic curve is y equals the absolute value of x. So I'll draw that in. Plus 2 is grouped with the x. So from what we saw yesterday, we're going to shift that curve 2 units to the left. And so there's our graph. And I've plotted a couple of points on there to give it scale. Because they've shifted to the left 2, we now have the 2 points, negative 3, 1 and negative 1, 1. Or, of course, I could do it this way. I could say, no. The basic curve is actually going to be y equals x plus 2. But the bit below, I'm going to reflect above. I get the same picture. 2 different ways of thinking about it. Y equals the absolute value of x plus 2. Basic curve, there it is, y equals x. But this time, I've shifted it up 2 units. So shift it up, and there it is. solving equations that involve absolute value. And this might look like a silly equation. And you might look at it and go, well, it's obvious what the answer is. And a lot of you might look at that and go, oh, it's x equals plus or minus 7. You are, of course, correct. When you get questions like this, because it all goes back to the definition. Remember the definition? It was either A, if A was greater than or equal to 0, or negative A, if A was less than 0. So we said there's two things it could be. So for this one I'm saying, well, it could be 2x minus 3 is 7, or the negative of 2x minus 3 is 7. So notice where I placed the negatives. I actually put it with the absolute value rather than the number. Now getting in the habit of doing that will come in very useful when we look at absolute value in equations. But that's later on, we'll look at that. But that's the habit to get into, either the positive of 2x minus 3 or the negative of 2x minus 3. Then we just go and solve each of those. So we get x equals 5 or x equals negative 2. And there's my two answers. But we do have to be careful when it equals algebra. So when it equals a constant number, nice and easy. But look what happens here. Absolute value of 2x plus 6 is 3x plus 1. Same idea, either 2x plus 6 is 3x minus 1, or the negative of 2x plus 6 is 3x minus 1. Left hand side I get x equals 7, right hand side I get x equals negative 1. And a lot of people would be happy to leave that as the solution, but they would be wrong. Because they forget to do one of the most important things when you're solving equations, which you're told to do way back when you start doing equations, but we fail to do it, and that is simply check your answer. Because have a look at x equals negative 1. Substitute it in, what do you get on the right hand side? Substitute negative 1 in the 3x minus 1, you get negative 4. And you're saying the absolute value of something is negative 4, which of course is impossible. So actually that's not a solution. Now what's happening here? Well, what's happening is what we've done, we started with this question and we've basically said, oh, this is too hard to do. So I'm going to change the question into something that's easier to do. And that's what we've done in the next line. I said, I'm going to make it these two. I use a solution to the new one that I've created, but it's not a solution to the original question. People don't check their answers, and that's where we come a cropper on questions like this. Watch out for that one. When absolute value equals algebra, only solution for this is x equals 7. It is only going to happen in an absolute value equation when you've got absolute value equals something with pronumerals. See, this one over here, not going to be an issue because it equals a constant 7. Not going to be an issue. This is when it might be an issue. So make sure you check. All right, that'll do it.